first talk of the day? Are you ready? Come on. All right, y'all are not ready. Can y'all stand up for a second? Come on, we're all asleep. It's day 3. Can y'all believe it? All right, stretch a little bit. Let's get ready so we can give our first speaker a nice round of applause and a welcome. Chad, are you ready? Well, y'all might have heard Chad yesterday. Ask a few questions. All right, can we give him a round of applause and please take your seats.
It's working. Good morning.
Good morning.
Thank you to our organizers and our sponsors for creating this space for us to learn from each other. There have also been some fantastic presentations this weekend or during this DevOps days, and I'm really honored to be a part of the group. Today I'm going to share with you what I know and what I've learned about DevOps, staff engineering, and platform engineering. In particular, I want to share with you and explore what these concepts, or whether these concepts have a place in a startup. I would argue they do, and I hope that you'll agree with me at the end. I'll be linking to various resources throughout this talk using QR codes. So if you see one and you're interested in what I'm mentioning, you can grab it then, or you can grab a QR code to the slide deck at the end of the talk. My name is Chad Mcelligott. I'm a senior staff engineer at Smarter, a New York-based startup that provides subscriptions and loyalty functionality to Shopify brands. I work remotely from Huntsville, Alabama, and I've been with Smarter for about a year now. We have 18 people in our product and engineering group, which is more than half the company as a whole. Smarter is a Series A startup. This means we've proven to investors we found product market fit and have received a round of funding. And we're now working to grow our customer base, broaden our reach, and stabilize our core offering. I joined Smarter a few months after we closed our Series A. I have a general staff engineering role, working on cloud infrastructure, but also helping to lead the product teams alongside our CTO and director of product. This role is one of leadership without authority. I help steer the direction of the engineering group through sound reasoning, leading by example, and earning the trust of my fellow engineers. I consider the concepts of DevOps, staff engineering, and platform engineering as tools to use to lead and build that trust. But what do these concepts, DevOps, staff engineering, platform engineering, what do they really mean? It's important to consider this when you're moving from context and environment, because you really want to try to understand the core of these concepts so that you can be adaptable. So maybe being at a DevOps Days conference, you feel like you have a pretty good understanding of what DevOps means. But even among us, it's unlikely we'll universally agree on this definition. To some, it's your job title. To others, it's a way of working. Perhaps you're a software engineer who's experienced DevOps as no ops, resulting in you having to handle all ops-related concerns yourself. Maybe you enjoy that, or maybe you feel like it's moving the industry backwards. To me, DevOps is a mentality of collaboration, automation of toil, and an embrace of modern tooling to sustain a fast flow of value to customers. It's not just leveraging the cloud, building infrastructure using code, or setting up CI/CD pipelines. And it's not just breaking down barriers to communication and collaboration. DevOps is a collection of these things, a recognition of how far we've come as an industry and the lessons we've learned, and taking advantage of that to achieve better outcomes for ourselves and for our customers. Now, platform engineering is a newer concept made popular by the book Team Topologies by Matthew Skelton and Manuel Pais. I gave a talk about my experience as a platform engineer at last year's DevOps Days, Birmingham. So if you haven't had a chance to check it out. I think of platform engineering as a technique for reducing the cognitive load on developers. It aims to increase product development velocity and system stability by putting in place foundational components that support the developer's activities. Listening to podcasts like the Engineering Enablement podcast, you can hear many stories about how large organizations are building platform engineering teams to reap efficiencies and improve the developer experience. Now, lastly, staff engineering isn't a mindset or a technique, but a role a software engineer plays within an organization, sometimes also called Staff Plus. A progression past the career senior software engineering role, staff engineering may be best described as servant leadership for software engineering. Senior software engineers are responsible for the outcomes of their work and the work of their team. Staff Plus work can grow this responsibility to the entire organization, but it may lose some of the individual contributorship a senior engineer may have grown accustomed to previously. Staff Plus engineers are often partnered with managers, directors, or VPs to bring IC-style boots-on-the-ground perspective, energy, and action to those agendas. There's a lot of overlap between the architect role of past generations and Staff Plus engineering. And Will Larson even calls out the architect as one of the 4 staff archetypes, the others being right hand, tech lead, and fixer in his book, Staff Engineer. So what's different about working at a venture-backed startup? Well, to grow the company, the leaders often hire up, often taking on more expenditures than the company's revenue, leaning on the capital gained from investors to provide a so-called runway to facilitate rapid growth. As a result, the company must move fast towards that growth and profitability before the runway runs out. This dynamic leads to 2 cultural qualities that I see a startup exhibits. First, there's no time to waste. While waste is never okay, it's particularly detrimental at a startup. The development team's activities have to be hyper-focused on the organization's strategic goals while there's still enough runway to execute on them. Everyone on the team needs to consider whether their activities are aligned with that strategy, and if they think they're off course, to check in and reorient. Experiments will often fail, but this isn't really a waste of time as long as they're structured for learning and the desired lesson is learned. And when an organization is small, like Smarter, there's a lot of work to be done and seemingly nowhere near enough people to do it. So we all wear many hats. As a result, someone who identifies as a front-end developer may also be performing the activities of a designer, a technical writer, a product manager, QA, third-party integrator, and more. As new ideas are brought to the table to further improve the customer experience, those same people who brought those ideas may end up being the ones to prototype or even implement them. These cultural qualities inform what is needed from a product development group, and in particular, a software engineering leader within that group. They can also give us hints about how DevOps, platform engineering, and staff engineering may need to be adapted to fit this environment. So let's talk about that adaptation. For DevOps, it's important to keep in mind that processes are easy to change at a startup, because there are so few people who need to alter their behavior. When looking to solve some problem, particularly when a tool is involved, it's best to alter your process to that tool and not vice versa. Keeping a rigid process would require you to customize your tools or possibly even build additional pieces of software, all of which are a drain on your time that could be better spent creating value elsewhere. Speaking of tools, you should try to avoid as much custom tooling as possible. This can take many forms, but may include using serverless infrastructure, leveraging SaaS tools, or choosing an open source library instead of building something from scratch. Try to go with the grain of the technology that you're using, where deviating doesn't provide a competitive advantage for your company, as it'll save you a lot of time and energy. Martin Fowler has a great article on his blog about this, titled Utility versus Strategic Dichotomy, if you'd like to learn more about the concept. Lastly, when you're choosing utility technology, you'll want to make sure it's boring. Don't make big bets on core solutions that are unfamiliar to the team or that have no community around them. If you encounter a problem, you want to be able to search for that problem online, not be forced to code one up from scratch. Dan McKinley has a full talk dedicated to explaining this idea at boringtechnology.club. So, how does platform engineering change at a startup? On Rebecca Murphy's new Engineering Unblocked podcast, something she said that I love is that a company's developer experience is a product, whether anyone designed it or not. This is really true even at a startup scale. Your developers will still need to monitor, deploy, track errors, read logs, flip feature flags. The question is it a pain to do these things? When thinking about platform engineering at an early stage startup, it'll certainly be a part-time hat that you wear. While at one point you may need an integrated testing environment separate from production, later you may find that your platform-related concerns are lower down on the list of priorities. You'll find yourself putting on that hat only as the need arises. You're also not likely to have time for long-term projects. Instead, think of how you can implement some value-added project or component of a broader solution that you have in mind. You can think big picture, share that grander vision with your team, but you really need to work in small batches and help people understand how these smaller pieces connect to your broader vision. Lastly, platform engineers at larger companies spend considerable effort ensuring smooth transitions from legacy software to modern tools and techniques. By contrast, doing platform work at a startup mostly involves putting components in place that didn't exist at all before. You'll be blazing a trail, unlocking new productivity for the team and approaches that were previously not even possible. This is a great feeling, but it can also be tricky to know of all possible things that I could do to improve the team, what should I be doing? When deciding to take a platform-related project, just make sure that you're solving problems your organization currently has and not applying things that are the technology du jour. Through boots-on-the-ground work, talking with your fellow engineers, paying attention to retrospective feedback, and periodic assessment of your SDLC metrics, you'll surface work that deserves attention. Sometimes, though, that work is not going to be as pressing as other concerns in your organization. It may be best to leave that platform work for another day, so try to be flexible. So lastly, staff engineering is really well suited to work at a startup. The inherent deep technical expertise, the interest in having a broad impact, and the willingness to go where needed to solve business problems all resonate really strongly in this environment. Now, there's a common saying in larger organizations that certain staff know where the bodies are buried, suggesting that they understand where technical debt lies and the context around it. It's often the role of a staff engineer to go and find those people, write down what they know, and use that to help the organization move forward. By contrast, when you join a startup, you can often just look around and see all the things that need work. You might even say there's a trail of unburied bodies at a startup. This is an opportunity for a staff engineer to have a tremendous impact through execution alone by reining in this chaos and putting in solutions that will serve the company for years to come. Now, staff engineers won't be able to stay in any one archetype at a startup. It's likely due to the small size of the group that you'll be expected to be hands-on in addition to other typical staff-related tasks. You'll be called upon for architecture, leading projects, performing tactical tasks, and will be expected to come up with your own ideas of how to improve the organization and make those things happen without being asked. Fluidity and ownership are key traits of a staff engineer at a startup. Lastly, one perhaps less mentioned aspect of staff engineering is the work that you do as a mentor and a sponsor for the other engineers in the organization. This can be especially important at a startup with junior talent because they need that support, guidance, and the guardrails that a staff engineer can provide. So now that we've looked at these concepts in the abstract, I'd like to share 2 stories with you about projects I worked on during my first year at Smarter and how I applied these modern engineering practices to my work. My first story is from the beginning of my time at Smarter. It's about the improvements we made to our QA process and how we no longer impose a merge freeze while regression testing our releases. Second, I'll share with you how we've evolved our processes as we continuously strive to improve how we organize ourselves to ship software. So let's dive in. When I joined Smarter, one of my first tasks was to help finish a project to provision a new integrated testing environment in Google Cloud. At that time, the process for performing releases was to stop merging patches into the main branch for 2 to 3 days, while the QA team walked through their manual regression testing process using Case, a popular QA test management tool. Any bugs found would be fixed immediately, their patches would be merged into the main branch, and a release would be cut and deployed to production. Then the developers would continue building as normal, pushing patches to the main branch, but leaving until the next deployment needed to happen. While the regression testing was happening, the developers would do work, push pull requests, but leave those pull requests open until the merge freeze was lifted. The team was operating using a 2-week sprint, and the regression testing process would start roughly 3 days before the end of the sprint. So while this process was working, it had its drawbacks. The fully manual regression testing process was slow, often had unpredictable results because of a lack of unit tests in fundamental areas of the code base. The development team understood the importance of quality, but was understandably frustrated by the merge freeze, which often resulted in difficult to resolve merge conflicts. Now, the organization had recently renewed its focus on quality and stability when I joined, leading them to reevaluate every aspect of their software development lifecycle. This resulted in a few new initiatives. Among these, they wanted to convert their manual regression testing suite into an automated suite using Playwright that could be run more often and more efficiently. The QA engineers wanted a stable, integrated test environment to run this against so that the application wouldn't shift under them while the suite was running. So this is where I joined the company to build this new environment. The application to be deployed to this environment was a monolithic node application along with a collection of cron jobs, some Google Cloud Run instances, a Postgres database, Redis instance, some Google Cloud pub/sub queues, and DNS. The application and its cron jobs were deployed to Google Kubernetes Engine. The source code was hosted in GitLab, and the GitLab CI config file was considered arcane knowledge. Most were afraid to touch it for fear of breaking something. Progress had already begun on this environment when I joined. There was already a new GCP project and a new cluster, and much was working. Even the Terraform was already being used to build out the infrastructure. I took the work that had already been done and applied what I felt was important given the situation, the team, and the timeline. So I felt it was important that the infrastructure code be co-located with the applications so that the developers would treat that code as a first-class citizen. I moved the Terraform project into the monorepo and tied it into our automatic linting and dependency management tooling. And while choosing Terraform was a really good choice, I felt it didn't go far enough because the other environments also needed this treatment. I went ahead and captured the existing staging and production environments in Terraform as well, then built the new environment's infrastructure by applying a different set of variables to those definitions. This ensured parity between the environments and helped us heal the places where they had diverged. Now, when Smarter CI was first set up, it was using GitLab's auto DevOps templates to get started quickly. Over time, though, heavy customization of this partially obfuscated configuration made the CI process difficult to understand and make sense of. So we decided to cut auto DevOps out entirely and explicitly define everything. We cloned the existing monorepo to a new project in GitLab, disabled auto DevOps, then built out a new GitLab CI YAML file that retained much of the GitLab specifics of the build, test, and deploy process, but split the majority of the commands off into a makefile so they could be run manually. Once we had this working, we merged it back into the main monorepo and disabled auto DevOps. Lastly, we decided to further decouple from GitLab by moving our secrets. They had previously been stored in the GitLab config for the project. While rebuilding the deployment scripts, I moved all the secrets to Google Cloud Secrets Manager, and the automated process of updating, or automated the process of updating the Kubernetes config map from these values on each deployment. And there were, of course, some things we decided not to do. The application running in Kubernetes kind of felt like overkill since we had a monolith. We decided to leave it this way, though, because it wasn't actively hurting anything, and it would have slowed us down to getting to our final goal. We also didn't set up any automated Terraform workflows, since our infrastructure was relatively simple and didn't change very often. We considered it a nice to have to automate it, but it's still a manual process even today. I have it on my list to investigate Google Cloud's Infrastructure Manager for automating it eventually. And while I did move our secrets into Google Cloud Secrets Manager, I decided not to set up a Kubernetes native way of accessing them. We weren't sure if we were going to continue using Kubernetes moving forward, so I punted on this decision and set up a stopgap instead. Time has shown that this decision was fine. We've since learned that we are sticking with Kubernetes because we have our temporal workers deployed into it. So I'll probably eventually set up something like external secrets operator for when we decide to start deploying new workloads into Kubernetes. So while we were still working on that new environment, I documented and shared my vision for eliminating manual regression testing entirely from our release process. Many were skeptical that we would ever achieve this, but folks were enthusiastic about moving QA to its own environment and removing the merge freeze, which was the first step to this larger goal anyway. And after much iteration and a careful rollout of this infrastructure to staging, then sandbox, then production, the project was a success. The environment was released about a month after I joined, and the QA team got to start using it. And once the new environment was available, we updated our release process so the QA team could block their deployments to the new environment while leaving the developers free to merge their changes into main without restriction. This is the release process that we still use today. I do maintain that we will be able to achieve the vision of continuous delivery. It'll just take us some more iteration to get there. So back to these three concepts that we've been exploring: DevOps, staff engineering, and platform engineering. How are these helpful in this story? Well, staff engineers are always eager to seek anyone who can help, no matter what team or role they have at the company. While working on this project, I spoke with practically everyone in the company to clarify, verify, and lead with intent. I played a tech lead role on this project, driving the project to completion, managing its scope, and making tough decisions along the way. Finally, I leveraged the project to make our infrastructure and CI/CD process more accessible and easier to understand, both of which are universal goals of a staff engineer. And while this was initially what you may think of as a DevOps project, I turned it into a platform project by altering the scope to fully manage our infrastructure with code instead of just the new environment. By making that change, Terraform is now the clear choice for all infrastructure moving forward for the engineers at the company. We're also less likely to encounter differences between environments as our infrastructure evolves, giving us a solid foundation to build upon. I did have to walk away from some nice-to-haves, but I felt these were good trade-offs, given the lateness of the project and pressing priorities elsewhere. And DevOps principles were core to this project, of course. We leveraged infrastructure as code to manage the cloud infrastructure consistently. We simplified and improved our release process once the necessary tooling was in place to support it. And I introduced the request for comments document format to the organization to facilitate inclusive decision-making as we defined our new process. So that was my first project. It felt really good to hit the ground running and have a win so early on. QA got the environment they needed, and developers no longer needed to artificially delay merging into the main branch. The whole org sped up a bit due to better tooling and processes for collaboration. I'd love to iterate more someday on this by building things like ephemeral preview environments or fully automating our regression testing. If these topics interest you, come find me later. Next, I want to shift gears a bit and show you another side of modern staff engineering, getting involved in shaping the processes that we use to do our work. So over the course of my year with the company, I've pushed our leadership team to continuously iterate on the processes and practices the engineering group uses to organize itself, to ship software. I believe there's no one-size-fits-all approach to building software. So I felt that by experimenting with different approaches that I've seen work well in the past, we could eventually collect enough signals to know what would work for this new team and group that result in productive collaboration. When I first joined Smarter, the product development group all worked from a single board and would meet every day and walk through it, delivering status updates to the rest of the group. There was a lot happening, but when looking out over the Google Meet call, you could see glazed eyes and people sort of checking out when it wasn't their turn to speak. As new features were being built, the responsibility of seeing them fully shipped felt diffuse. No single engineer felt that it was their responsibility. So it often fell to the product manager to make sure that the feature was fully delivered to customers. There was also no clear understanding of the technical architecture that was being constructed during feature development. In summary, there were processes in place, but I felt we could do a lot better. Now, I've worked places that felt engaging, empowering, and thoughtful every day. I wanted to bring this feeling to my new group, and given my new role and the startup environment and culture, I felt empowered to do that. Smarter doesn't have any formal engineering management in place, so I collaborate with my amazing colleagues, CTO James Turnbull and Director of Product Bianca Tompkins, to fill the gap and provide support to the engineers. Together, we regularly discuss ways to improve in all of these areas and more. Then I draft proposals for any changes that we want to try out. Each time we implement a new idea, we frame that change as an experiment, which I've found reduces the friction of that change and helps folks understand that these are not a one-way street. We always make the goal of the change clear, so everyone can decide for themselves if we're hitting that mark or not. In this way, we make any sort of process change a group endeavor. And in our retrospective meetings, we discuss whether or not a given change is having its desired effect. So I'd like to share some of the process experiments we've run, the goal of the changes, and some of the outcomes that we saw. First, we ran an experiment to move from individuals working tickets across the board to instead running short-lived feature teams. The goal of this experiment was to build a sense of direct responsibility for the full life cycle of feature development within engineering. We would choose a lead for a feature who in turn would pick a cross-functional team to help them implement the feature to its outlined acceptance criteria. The outcome of this experiment was sort of mixed. We definitely saw an improvement of team members' sense of ownership over features, but not everyone wanted to be a lead or felt they were well suited to be one. So after trying this for a few months, we decided to change this to a new fixed team model with static leads that we call squads. These squads run their own planning and their own retrospectives, giving them more autonomy and ownership over their process. Second is our epic kickoff document experiment. The goal of this experiment was to ensure that requirements were clear as people were starting new bodies of work. And the entire team is on the same page regarding the scope and the approach that will be taken prior to starting. To make this change, we provided a template for the teams to populate during a meeting where they could cover all agenda items highlighted in the document and add any additional context that they felt was important to share. This document can be referred back to throughout the project to clarify the original plan. So the outcome of this change was really positive. The document only really served as a prompt, a way for people to not feel lost when first beginning these meetings and opening up communication between each other. The team members now felt these meetings were a good value for the time spent, and they operate better earlier on in projects with less confusion. Lastly, I'm excited to share my favorite experiment that we've run, our group code review. The goal of this experiment was to reduce code review turnaround time, encourage discussion of code, share skills between the engineers, and more. To achieve this, we decided to try meeting twice a week in an optional 1-hour Slack huddle where developers can join to review code or have their code reviewed by others. A driver shares their screen and walks through the pull request. The attendees share their thoughts and make suggestions. This has had a huge positive impact on our engineering group. By reviewing each other's code in person, they naturally treat each other humanely and respectfully on the call, and they take that back to comments even outside the call. Comments made in the call result in thoughtful discussions about techniques and trade-offs, which leads developers to learn a lot from each other. Pull requests never sit very long because we always are working to reach inbox 0 in these sessions. More code reviews are happening now, even outside of these group code review sessions. This has also given the team exposure to the benefits of things like pairing and grouping up for coding, which I'm hoping to push more for as time goes on. We've had multiple retrospectives on just this one piece of process and have, after a year, decided to keep it as a staple of our collaboration. So let's check in with these engineering concepts again and see how they've influenced this type of work. So adjusting process for teams is usually thought of as the role of an engineering manager or a director, but in their absence, a staff engineer with an interest in these sorts of improvements can get involved and really have a good impact. Once the culture of continuous improvement has caught on within the teams, they'll start to feel empowered by their agile processes instead of burdened by them, and can take on the challenge of further process improvements themselves. Sometimes teams get stuck in process ruts that are dragging them down, but they're not aware of it or they become used to it. Having a trusted staff engineer to kind of go in and shake things up a bit and show a better way can be just the medicine a team needs to realize their full potential. And while much of the buzz around platform engineering tends to revolve around tools, my hot take is that process is also a part of your platform. Process plays a large part in the speed and effectiveness of your engineering org, so it should be thought of as an enabler alongside your tooling. An ineffective process is an impediment to a team's developer experience, so replacing it can be just as impactful as improving build times or reducing toil during deployment. Process is also a lot easier to change than tooling. As for DevOps, well, consider the acronym CALMS, which is often cited when DevOps is defined. It stands for collaboration, automation, lean, measurement, and sharing. The lean part refers to using lean processes to eliminate waste in the value stream. Iterating on your processes through Agile and teaching others how to do so is a core aspect of DevOps. So I strongly encourage you to take a hard look at your own processes and decide if you have any room for improvement. It's a low effort and high impact way to change things that can make a huge benefit for everyone. So I'm really enjoying my time working in a startup environment. At this stage of the company, I feel I'm bringing my full self to the problems we're solving and can work across disciplines to help bring solutions to life. The ever-present time constraints force pragmatism, an important skill to cultivate no matter what industry or environment you're working in. The embryonic nature of this company gives me the opportunity to make a huge impact and set the company up for success by applying a modern approach to software engineering. Now, staff engineers often require breadth and depth of experience to be successful in their role. Working at a startup is a great opportunity to further develop your breadth and perhaps try out an area that you may not have had a chance to dig into before. Have you primarily been working as a back-end engineer, but maybe you're interested in developing some like React skills or BigQuery skills? A startup is a great place to do this. Platform engineering will look different at different scales of companies. At a startup, you'll be able to sit down one-on-one with engineers to discover their pain points, then take on small projects to move that needle in a better direction. Building fast feedback loops into the development process is a great way to improve developer experience and help them help themselves. And you'll want to ensure that all your basic SDLC concerns are covered with industry standard tools and techniques. Platform engineering isn't going to be a full-time job at a startup, especially a small, early-stage startup, but a technique you apply when the need arises. Remember, a company's developer experience is a product, whether anyone designs it or not. So, design it. I hope you agree with me that DevOps is very relevant at a startup. Putting in place the culture sorry. Processes and tools that accelerate value delivery to customers and making a company a humane place to work is very rewarding for everybody involved. So if you're a DevOps enthusiast and you're considering working at a startup for the first time, I definitely recommend it, and I think you'll find you have a lot to bring to the table. That's it. Thanks.
Thank you very much, Chad. That was awesome. All right.